Hi, thanks for joining me. Today I'm going to be going over problem 3 from the 7th week of the Summer Invariance Maths competition. As always, I'll leave a link in the description below with details of the competition. Anyway, this is the problem I'm going to be tackling today. I have a square and I have a guy called Brian in the middle of the square. And on the corners of the square I have 4 wolves, wolf 1, wolf 2, wolf 3 and wolf 4. Now Brian is a strong guy. If he takes a fight on with one of the wolves, he'll be able to beat one wolf. However, if he tries to fight more than one wolf at one time, he will not win. So if he took on, say, wolf 1 and wolf 2, the wolves would beat Brian and they'd be able to eat him. Now, Brian wants to escape the square, of course, without being eaten. And the wolves' goal is to try and eat Brian. Now, the wolves are clever. They're working together to try and eat Brian. And Brian, of course, is just by himself and he wants to escape the square. Now, one fact is Brian has a constant speed, he can move at a maximum speed of, say, 1 unit per second, but the wolves can move at 3.5 times his speed each, so each wolf can move at a maximum of 1.5 units per second. Is there a strategy Brian can employ to escape the square, or is there a strategy that the wolves can employ so that they can always eat Brian, i.e. there are always 2 wolves meeting Brian if he tries to leave the square? Of course, Brian doesn't want to stay in the square because then he'll starve, so he does have to try and leave the square, but the wolves want to eat Brian. So is there a way? And that's the problem. I'll leave a worded description of the problem in the description below if my one didn't make sense, but hopefully it did. If you want to have a go at the problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so the solution to this is that the wolves can always win. In other words, there's a strategy which the wolves can employ so that if Brian ever tries to leave the square, he'll always be met by at least 2 wolves. Okay, and I'm going to discuss one strategy, but I encourage you to have a play about and see if you can find other strategies in which the wolves can use to always find Brian. Okay, and in this proof, I'm going to be using the fact that root 2 is less than 3 over 2. Not too difficult, you can shove it into your calculator to check, but just to convince yourself, this is true if and only if, when I square both sides, I get the same thing. Okay, notice that the inequality doesn't change sign because everything's non-negative. So this is true if and only if 2 is less than 3 squared over 2 squared, which is 9 over 4, which is the same as 2 plus a quarter, and of course 2 is less than 2 plus a quarter. Okay, so that means that root 2 is less than 3 over 2, and in fact root 2 is 1.41 something? I don't know, 1.4 something. That's irrelevant for the problem, just the fact that root 2 is less than 3 over 2 is enough. Okay, and you can see here what I've done is I've rotated the square, so now we're sort of looking at it from sort of a 45-degree angle, so it looks a little bit like a diamond. Now what I'm going to do is, just to make sure we can follow things nicely, is draw on an XY coordinate plane. Okay, so let's put on our x-axis here, and a y-axis here. Okay, and of course Brian is originally at the point 0, 0, and now without loss of generality, we're going to assume that that distance there is 1, so the sort of border represents the equation x plus y equals 1, where we're looking at the magnitudes of x and y. Okay, now what I'm going to do is talk about the strategy wolf 2 and wolf 4 are going to use to home in sort of on Brian, and a similar thing will apply for wolf 1 and wolf 3, and then we're going to see that if Brian ever tries to leave the perimeter of the square, he's always going to be met by at least 2 wolves. Okay, so wolf 2 and wolf 4, they're going to maintain Brian's y coordinate. Okay, so for example, if Brian goes here, let's call this point x, y, then wolf 2 will move along this line up to this point here. So the point with the same y coordinate that's on this line here. And similarly, wolf 4 will move to this point there. Okay, so the point on this line with the same y coordinate. Okay, firstly, let me prove that these wolves can certainly keep up with Brian. Again, it just boils down to this fact here. Okay, so suppose Brian moves to a general point xy in the square. Okay, let's look at wolf 4. So let's look at this right-angled triangle here. Okay, so let me just blow it up and draw it here. Okay, so I'm just looking at this right-angled triangle here and bringing it here. Well, what's the height of this triangle? Well, it's y. Okay, what's the base of this triangle? Well, it's also of length y. And the reason for that is because this line here has gradient -1. So that means that this length is the same as that length. Okay, Pythagoras' theorem tells us that this length here is y times root 2. Okay, now the time it takes Brian to get to the point xy, so let's call that TB, is going to be at least the shortest possible time it can take him to get there. Now, of course, the shortest possible time it can take him to get there is by travelling in a straight line, and the distance of that straight line is square root of x squared plus y squared, but in particular, that's greater than or equal to y, okay? Because x is real, of course. Okay, so the time it takes Brian to get to that point there, TB, is going to be greater than or equal to y. But now the wolves, remember, they can move at a speed 3/2. So the time 3/2 times the speed of Brian. Okay, so the time it takes the wolf to get to that point there is simply going to be that distance times 2/3. Okay, what is that distance there? Well, it's root 2 times y times 2/3. But in particular, because 3/2 is bigger than root 2, that means that 2/3 of root 2 is less than 1. So that means that this thing here is going to be less than y. So that essentially means that the wolves can always keep up with Brian. So if Brian moves here, say, then for a similar reason, wolf 2 will also be able to get here in enough time. And similarly, wolf 4 will be able to get to this corresponding point in enough time. Okay, so the wolves can keep up with Brian, so this strategy holds. Okay, and with a similar argument, I'm going to show that the wolves for wolf 1 and wolf 3 can also keep up with Brian. And what they're going to do, wolf 1 and wolf 3, is they're going to maintain Brian's x coordinate. Okay, so wolf 2 and wolf 4 maintain Brian's y coordinate, and wolf 1 and wolf 3 are going to maintain Brian's x coordinate. Okay, so for example, if Brian moves here to this point here, then wolf 3 is going to go to this point here. Okay, and wolf 1 will move to this point here. And we know that for a similar reason for why wolf 4 can keep up with Brian in this scenario here, wolf 3 and wolf 4 can always be at this x coordinate here. Okay, and so the wolf 1 and wolf 3 can always keep up with Brian's x coordinate, and wolf 2 and wolf 4 can always keep up with Brian's y coordinate. Okay, now suppose for contradiction that Brian can escape the square unharmed. So he can take on maybe one wolf, that's fine, but that's it. So there's a way in which Brian can leave the square meeting only one wolf. Okay, let's say it's here, for example. So Brian leaves the square, he might take some convoluted route, it doesn't matter, but he gets to that point there. Now, wolf 4 is going to maintain Brian's y coordinate, so wolf 4 will be here. Wolf 4 will be waiting for Brian, okay? But also, wolf 3 is going to maintain Brian's x coordinate, and he's going to also be there waiting for Brian. So Brian will be met by two wolves, and that's game over for Brian. Brian will be eaten by wolf 4 and wolf 3 in this scenario. And of course, you can generalise this. If Brian ever tries to leave the square, he's going to be met by the two wolves corresponding to that quadrant. So if Brian tries to leave there, he's going to be met by wolf 1 and wolf 4. And that essentially boils down to the fact that all the wolves will be able to keep up with Brian in some coordinate frame. So wolf 1 will be able to keep up with Brian in their x direction, and wolf 4 and wolf 2 will keep up with Brian in the y direction. Okay, hopefully that explanation has made sense. Perhaps there are other strategies that the wolves can use in order to escape the square, but this is quite a neat one, not too difficult to explain, I think. I hope that made sense. But anyway, I hope you have enjoyed this video. If you are new here, please do check out some of my other maths videos as well. I don't just make these solution videos. But yeah, I'll catch you in the next one. Have a great day.